Hi, in the last session, we talked about VHDL sequential statements and we covered if-else statement and case statement. Now let's talk about for loop statement in VHDL. We will see how to use for loops in VHDL, how it works, and we will also see that how it works in real hardware. We will also cover important tips and tricks about for loops in VHDL designing. So let's start. In VHDL, for loops are used to repeat a section of code for a fixed number of times. And because it is a sequential statement, that means it must be written inside a process block. Here is a basic syntax of for loop. And you can see the keywords which are highlighted with blue color. So before we start, let's have some basics first. So for loop uses loop variable to control its loop execution. The loop variable can only exist within the loop and cannot be accessed once loop is completed. The syntax for a for loop in VHDL begins by declaring a loop variable name and the number of iteration. So it is for then loop variable name in range loop. Now you will write the code here that needs repetition and a loop semicolon. Here is a quick example of a for loop in VHDL. So it is my loop colon process a comma b begin for I in 0 to 2 loop d out I gets the value of a 2 minus I and bi semicolon and loop and process. Here I is our loop variable which have the range from 0 to 2 means total 3 cycles of repetitions. For the first iteration value of I would be 0. Then for the second iteration, value of I would be 1. And for the last cycle, value of I would be 2. Now here are a couple of important terms about for loop. The for loop uses a loop variable to control its execution. This loop variable exists only within the loop and cannot be accessed once loops gets finished. The loop variable name must be specified at the beginning of for loop. The code inside the for loop can use this variable name to access the loop variable. Each repetition of the for loop is called an iteration, and the range specifies that how many iterations will occur. Now here is a simple example to specify the range in for loop. Let's say we specify a range from 0 to 2. This means the for loop will run 3 times in total. In the first iteration, the loop variable will be 0. In the second iteration, the loop variable will be 1 and so on. In this example, for loop is written inside a combinational process block. The first line declares the loop variable I and the number of iterations. So the loop variable I goes from 0 to 2. So there will be total 3 iterations. In the first iteration, I will be 0. And in the second iteration, I will be 1. And in the last iteration, I will be 2. And the code inside the loop will be repeated for each iteration. So the for loop will essentially generate these 3 statements shown here in the bottom section. So d out 0 gets the value of a2 and b0. d out 1 gets the value of a1 and b1. d out 2 gets the value of a0 and b2. Let's see how this works. So for the first iteration, I is 0. So we replaced I with 0. So we have our first statement as d out 0 gets the value of a2 and b0. Now for the second iteration, I is 1. So let's replace I with value 1. And we have our second statement, which is d out 1 gets the value of a1 and b1. In the third iteration, I is 2. So again replace I with the value 2. And we have our third statement, which is d out 2 gets the value of a0 and b2. Means both of these codes in these 2 separate blocks will give you the similar output. Means both of these codes are exactly same and will generate the same hardware. So you can use both ways here. But assume that the iteration is 100 times for your requirements. Then in traditional approach, you need to write 100 statements. But with for loop, you can achieve the same thing with very few lines. So that's where you can prefer to use for loops in VHDL. But you need to remember is that the for loop replicates the statements written inside the for loop. Now let's see the hardware implementation of for loop. So as we know that the evaluated code translated into the AND gates, like we explained in the last slide. On the left, we have inputs like input A and input B. These are 3-bit STD logic vector signals and having range 2 down to 0. On the right, we have our output Dout, which is also a 3-bit STD logic vector and having the range 2 down to 0. And there are 3 AND gates generated with the 3 different indexes, which are mentioned in the structure, and they are corresponding to their each output index. Now we will talk about for loops in the registered process block. Here is an example of using the for loop in a registered process. We are using the same for loop example as before, which evaluates to the 3 statements. So for a registered process block, we have reset and clock sections. In the reset section, we set all the signals to their default state. So Dout is 0, 0, 0. In the clock section, we write our for loop just as before. So this is our complete code. My process colon process reset and clock begin if reset equals to 1, then Dout gets the value of 0, 0, 0. Else if for the rising edge of clock, then for I in 0 to 2 loop, Dout I gets the value of A2 minus I and Bi semicolon and loop and if and process. Now let's look at the hardware visualization of our for loop in the registered process block. You can see 3 AND gates. These are just exactly same like we have before. Here the only difference is that we have added 3 flip-flops at the output of the AND gates. Note that for simplicity, I have not included the clock and reset signals here, but they are also connected with these flip-flops. So here are some useful tips about for loops. First, you can use array attributes to define the range. Here we have some for loops as in our previous examples with signal A, B and Dout. In the second box at the bottom, I have written the for loop slightly differently. So you can see I have used the right and left attributes of Dout to define the range. So I have written for I in Dout right to Dout left loop, Dout I gets the value of A2 minus I and Bi and loop. The right attribute of Dout returns 0 and the left attribute returns 2. So ultimately for loop range will be 0 to 2 for our example. The advantage of this approach is that if the size of Dout changes, then the number of iterations will automatically adjust to match the size of Dout. In the another example, I have used the range attribute of Dout, which returns 2 down to 0. So I have written for I in Dout range loop, Dout I gets the value of A2 minus I and Bi and loop semicolon. Now let's understand this. Although the final output would be same here in terms of hardware generation for this example of AND gate, but the processing is little different because so far the loop variable in our for loops was counting in ascending order, means from 0 to 2. However, for this code, our loop variable is in the descending order. So it starts from the 2 and it will go down to 0. This means the statements will execute for I equals to 2, then I equals to 1, and finally I equals to 0. Another important keyword is exit, which you can use in for loops to take the early exit from the loop. In this example, we are running our for loop for 8 iterations. The loop variable will start from 0 and it will repeat itself for up to 7 cycles of repetitions. So the first iteration starts with I equals to 0. The second iteration with I equals to 1. The third with I equals to 2. And the fourth with I equals to 3 and so on. Now suppose in some condition we want to take the exit from this loop cycle. And this is possible with the exit statement. So here is a simple code. Note that this time we haveTout, and this Tout is a STD logic vector signal and it is 8-bit long. So our code is for I in 0 to 7 loop, Dout I gets the value of 1. If I equals to 3, then exit. And if AND loop. So we specified the condition that when I equals to 3, then exit the loop. So you can see that the if condition is true when I equals to 3. So we exit the loop. There is an alternative way as well of writing the same code, which you can see in the second example. Here I have used when statement instead of an if else statement to exit the loop. So I have written for I in 0 to 7 loop, Dout I gets a value of 1, exit when I equals to 3, and loop. And these two statements are equivalent to each other. Now here is an important key point to note about the for loop, that you cannot change the loop variable inside the loop. Here is an example of a violation that we try to change the value of I to 3, and this is not allowed. Okay, so that's it for today. Hope this was an informative session for you. This was pretty basics about the for loops in VHDL. We will practice it more in the practical sessions later. In the next session, we will be talking about wait statements in VHDL. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to our community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.